This is my setup of the Michelson interferometer based on this laser diode. I plan to change this laser diode into this like the helium neon gas laser, so I want to record a video about this laser diode first. This is the basic setup of the classical Michelson interferometer. The laser goes through this laser diode into this beam splitter. This beam splitter will split the beam into two beams. One goes going to this mirror and bouncing back. Another one goes through this mirror and bounce back. So these two beams will combine together into this beam splitter and then goes through this beam splitter. You will see a interference pattern here. But this is just a dot. You cannot see the fringes move here. Even I use my finger to touch the breadboard and press the breadboard. It's hard to see the fringes move, but from my naked eye, I can see this laser dot tend to like dark and bright again and again. It's hard to see in this video. So I plan to use this convex lens to like magnify this pattern. But when I insert this convex lens into this beam path, it's still hard to see the pattern in the screen. But from my naked eye, it's very clear. When I push this breadboard, I can see the fringes move back and forth, move back and forward. So I use another photo detector here. This is a Newport photo detector, and connect this photo detector to this oscilloscope. Now I move this convex lens and move this small screen here. So it's clear. We can see this form on this camera screen. So even I speak here, and you can see my voice will pick up by this Michelson interferometer. It's quite sensitive. So even I just touch this breadboard here, you can see there's a lot of signal here. And even I use this wrench to just knock the desk or even knock the wall. It's quite sensitive, but the quality of this beam is not very good, and you can see there is a dot on the screen, but actually from this laser diode it's not a dot here. Theoretically it's like a ellipse shape, but from my naked eye I can see it's most like a rectangle beam here. So we need to use like a cylinder lens to make it to be a cycle shape. But I want to change this laser diode into this this helium neon laser, and the beam shape will increase significantly. Use this Michelson interferometer, we can measure the displacement. So previously I plan to use this linear stage to measure the beam or the wavelength of this laser, but I find this Michelson interferometer is very sensitive, and it's really annoying to read the black or dark or the bright fringes just by changing the knobs. So I give up this idea. For the setup, if you have the exist mount like this mount from Thorlabs or Newports, it might be easy to set up this interferometer. But without this mount, it's slightly hard, because you need to just combine these two beams into one dot here. Also, I plan to put like a beam expander here, but this distance is too small to play a beam expander. So I want to change this configuration, and this is just to record my current setup of this Michelson interferometer. I think that's all.